Hello, chemists. We have a couple more topics we want to talk about with our solutions, and the last two topics are dilution and osmosis. So we're going to jump right into dilution. Let's see if I can get there. Here we go. So we'll talk about dilution here, the concept of it. So basically, I'm sure you've done a dilution before. I'm sure that you have taken something that was more concentrated, like orange juice, and you've added water to it, which is basically adding solvent, right? And you've come up with so if we take a concentrated orange juice, back in the day, that's how we used to do it. We used to buy a frozen can of orange juice and add 3 cans of water to it to get a dilute solution of orange juice. Okay, so basically that's the idea of dilution. Perhaps you've taken a hydration pack, like some sort of powder, that maybe is a hydration. You added water and you diluted that powder into something else, something less concentrated, basically. So this idea of dilution is basically taking solute particles like these right here, and adding solvent. So basically we add solvent, and we still have the same number of solute particles, but they basically have more space, and so we've made a dilute solution. And basically, the formula that you would use is very universal. It doesn't matter how you measure the concentration, and we've talked about many different ways of measuring concentration: grams of solute in milliliters of solution, milliliters of solvent in milliliters of solution, molarity. You can do any measurement of concentration, and the formula always applies. So basically, if we have, the formula is the initial concentration times its volume, okay, is equivalent to the final concentration times its volume. And that formula right there, we're just going to practice working with and talk a little bit about how that looks. So I'm going to slide over to the next page and talk about this idea of dilution. And hopefully this is something familiar to you. I always like to mention, a 10% bleach solution is a common solution that's used in the food and the healthcare industry. And usually you take concentrated bleach, right? Concentrated bleach out of a container, and you add water to it, and you make that 10% solution. You probably have some formula that somebody's provided for you to make it super easy for yourself, but basically that's how it works. So we're just going to do a couple problems, and as per usual, I'm going to leave you guys to kind of work on the rest of them. But in general, we're just going to work through how to make a concentrated solution. So first and foremost, we're going to start off with a concentrated solution. So we're taking 5 milliliters of a sucrose solution. So this is just sugar, right? We're diluting sugar. And so we have our initial concentration of 5 molar. That's a chemistry measurement of concentration, as we spoke about before. And we want to make a 4 molar solution. So we're going to dilute it. So the concentration is going to go down. We're diluting it. And we want to make our second volume, we want to make 45 milliliters of it. So what we have is we've got this beaker, and of course I'm going to draw this out for you. We've got our solution here, and we've got our particles in here, and the concentration is 5 molar, right? Our job is to figure out, well, how much of this do we take out? So we got to pour a little bit of it out into our beaker right over here, right? We're going to pour out a certain amount of that, and then we're going to add a bunch of water to it, right? And so I'm going to add to this question just a little bit. The total volume we want in the solution is going to be 45 milliliters. That's what's given right here. And the concentration of this, we want this to be a 4.0 molar solution. So if we just take our formula is C1V1 is equal to C2V2. We're just plugging and chugging here. So we don't know, we do know the volume, we knew the concentration is 5 molar. We don't know V1. We know the concentration we're trying to achieve is 4 molar, and we know we want 45 milliliters of it. So basically a little bit of algebra here. We're going to rearrange this equation. So we are basically solving for V1, which is a little bit of algebra. We're going to divide both sides by 5 molar. Divide both sides by 5 molar. And we end up with V1 is equal to 4 times 45 divided by 5. So if we do that math and making sure that we do that correctly, dividing by 5, we get 36 milliliters. And I'm just going to point out that you'll notice that the units cancel nicely. Moles cancel, molarity cancels with molarity. I'm left with milliliters. So that's just saying, in order to make this solution right here, we're going to pour out, right? We're going to pour out 36 milliliters of our 5 molar solution. And then it's interesting to kind of think this through a little bit, and it's not asked in the question, but the question here is, how much water do you have to add? Well, if I know I want 45 milliliters of it, and 36 milliliters of it is basically our concentrated solution, basically we just have to add 9 milliliters. If we subtract those, we know this is going to be 9 milliliters for a total volume of 45 mils. Okay, so that's the game that you're going to play. Okay, and that is, you can practice that right here, and again I'll let you guys practice those so that we have those answers for you eventually. Okay, this formula of concentration is a pretty relevant formula. Again, if somebody's created a sort of cheat sheet for you at your workplace where you're making a 10% bleach solution, they've probably done this calculation for you, and that is reasonable to make it easier for you to do that. Okay, dilution. One of the things we do with solutions often, Scott does this readily in the back room when he's making solutions for us to use in lab. Okay, thanks for your attention. One more video on osmosis and we'll be finished with solutions. Have a great day.